Yes, sir.
Yes, sir.
Yeah, so now what is happening is the sessions will be conducted in this fashion that one my colleague, he will be taking the sessions on Fridays, okay, and I will be taking the conducting the sessions on Saturdays. So the thing is that in my sessions on Saturdays, I will be covering topics and solving problems which will be relevant for that particular week's assignment. Okay, I will be solving problems which will help you in attempting that particular week's actual assignment. Okay, so let's say this is week one, right? So in this week's today in the session, what I will be doing is I will be solving some problems which will help you to solve your assignment problems, week one assignment problems. Okay, so my colleague, the one who will be taking sessions on Fridays, what he will be doing is he will be solving the problems which have been given in the previous assignment in this particular course. So let's say this is in next Friday. Okay, what he will be doing the next Friday is that uh, not next Friday but next to next Friday, because the first assignment due is when, due date is when, it is on 9th of August, right? So after 9th of August, the very first Friday after 9th of August, my colleague, he will be actually discussing the assignment that was due on 9th of August. Okay, so his part of the job is to discuss. Yeah, so whoever is unmute other than me, please mute yourself. Kindly mute yourself. Yeah, thanks a lot. So am I audible? Clearly audible now? Yeah.
Yes, sir.
Yeah, yeah, fine, fine. Thank you. So what I'm saying is, the plan is that I will be discussing, I will be solving the problems which will help you with that particular week's assignment, and my colleague, he will be solving problems of that week only, just after the assignment is due. Okay, he will be basically solving it and and asking you if there are any doubts in that particular assignment or not. So is that clear for everyone?
Yes, sir.
Yeah, fine. So proceeding. So you all know what is going to be taught in this course, basic electrical circuits, right? You must have seen the rough outline. the syllabus for this course. I'm sure you must have seen that. And so, if I mean, you all are well aware of the course modalities now, so there's no point discussing that. So I'll quickly delve into this week's content because it's already late for me today. So let's start solving some problems. And don't worry about the about my video. I mean, ideally I should also be present in the video. However, my camera is not working today, so please bear with me for today. I will fix it next time so that it becomes more interactive in that way. Fine. So yeah. So this is the very first problem. So in this week you learned about a lot of basic stuff, right? What is a charge? I mean, what is voltage? What is current? What is Kirchhoff's voltage law? What is Kirchhoff's current law? You also learned about the basic circuit elements like resistor, capacitor, inductor, mutual inductor, right? You all have seen these things in this week's content, right? So now let's start. So this sessions will not be like I will be solving completely. I will be asking you, and you will help me solve these problems. Okay. Otherwise, it will be simply a boring lecture to attend to. Fine. So tell me, what should I do here? So the question is, you see this figure here, right? You see this. Sorry. You see this figure here, right? This is a simple circuit. Now you have been asked to find the current I that is flowing in the given figure. So this is the current that is flowing. Okay, and you have been asked what is the current here. So can anyone volunteer and tell me what should I do here?
Kirchhoff's current law.
Yeah, right. You have to apply Kirchhoff's current law, correct? So what should I do here? I mean, how should I go on applying the Kirchhoff's current law? Tell me.
So 3 and 4 amperes are entering at the junction, sir. Middle
This point, right?
Yes.
Yeah. So
And 7 amperes is going out, so no current through the other things, other lines.
okay, so basically you are seeing that this current and this current are entering, and this are leaving, and they amount to 7. They basically cancel each other, right? So you
Yes,
are saying that there should be no current here, 0 and 0.
Yes,
You are saying.
Yes, sir.
Is it so? I mean, one can also come up with a possibility like this, right? That some current is flowing here in this direction, and the same current is flowing here in this direction. Is it not possible?
Possible, sir.
Yeah. So this is. I mean, this is possible, right? So that is why you cannot guarantee it in that manner, correct? Am I right?
Yes, sir.
Yeah. So what else should I do now? I mean, do you see? Do you see any other possibility where can I use Kirchhoff's current law to get a definitive answer of the current flowing in the branches? So what about this node? Yeah, someone already said in the chat box that it is 1 ampere. So whoever is saying it is 1 ampere current, I should be 1 ampere. Can you please come ahead and elaborate on your answer? How did you come up with this answer? Hello. So I think someone answered in the chat box that it is 1 ampere. So could you please kindly elaborate?
The current in
Yeah, go on.
so it's 1 ampere.
I couldn't hear you. Could you please speak up? Okay, all right. So anyways, so focus on this node here. Okay, focus on this node. You see here, the current that is coming at this node is 2 ampere in this direction, correct? It is leaving this, the current leaving this node is 1 ampere. So what about the current in this branch here? What is this current? Let's call it
1
I.
ampere.
1 ampere, will it be in this direction only, the direction that I showed, or is it the other way around?
Yes,
Same
sir. Yes,
direction.
Same direction, right? So it should be 1 ampere, correct? So okay, so now you have this current in this branch flowing in 1 ampere in this manner, and at this junction 3 ampere current is flowing here, right, in this direction. So what about the current in this direction here? What should be the current here?
Minus 2 ampere.
yes.
Correct, minus 2 ampere. So everyone is following me, right? It's basic KCL, right? It is basic KCL here. It should be minus 2 ampere, or if the minus sign is minus sign is basically telling me that the current should have been in this direction, right? So it is 2 ampere in this direction, 1 ampere in this direction. So a total of 3 ampere will be flowing here, correct? So this is fine. Now look at this junction here. 2 ampere is flowing in this direction here. 4 ampere is flowing in this direction here. Okay. So what about the current which is flowing in this direction? What should be the current here?
Current, sir.
6 ampere.
6 ampere. Are you sure?
Yes, sir, sure. 6 amperes.
Good. So it should be 6 ampere in this direction, right? The direction is right, correct? Fine. Now we have this node here. The current here is 5 ampere in this direction, 6 ampere is flowing out of this node here, correct? So what should be the current I here?
1 ampere.
1 ampere coming, sir.
So it should be 1 ampere, right? It was very simple. Current should be 1 ampere, correct?
So
Fine. Very good. So that concludes the very first problem. So it was easy, right? Let's move on to the next problem. All right. So now tell me what is the so the question is, what is the value of current I in the below circuit? So this is the current I here. So what is the value of this current? So tell me, how will you find it out? First of all, let me draw the circuit in a different manner so that you might be more comfortable. So the same circuit, it can be drawn like this. Let's call this node as A, this node as B. Okay, so let's call this node as A and B. Okay, so in this scenario, all right. So whoever is saying the answer, please hold on a minute. This is 3. Okay, so this is 6 ohms, 6 ohms, right? Now between A and B again, we have 3 ohms and 3 ohms. This 3 ohms and 3 ohms, right? So let's 3 ohms here, 3 ohms here. Again between A and B we have 2 ohms and 2 ohms, right? Sorry, my drawing skills are not very good. Here it is. So this is 2 ohms. This is 2 ohms. Correct? Now between this node, the 6 and 6 and 3 and 3, we have 3 ohms, right? This one. And between this 3 and 3 and this 2 and 2, we have this 2 ohms, correct? let's do that. All right. And now to complete, we have between A and B, we have a voltage source like this, which is actually equal to 6 volts. And you have been told to find this current, right? Current I. Now the guy who was telling me that the answer should be 3 amperes, could you please elaborate on your answer? Yeah, hello. Could you please elaborate on your answer? The one who was saying that the answer should be 3 ampere. Akash Harshit, I guess that was the name. So you're saying the KCL at the top vertices of the points of the hexagon. Okay, so Mr. Akash is saying that we have a Wheatstone bridge here. So other guys, so do you remember what a Wheatstone bridge used to be? So recall your class 12th or 11th, I don't know, high school physics, and in that you must have learned about a Wheatstone bridge, right? Which used to be like this. This is R1. This is and let's say this is R2, this is R3, this is R4, this is R5. So when do you say that it's a balanced Wheatstone bridge?
When the current in R5 equal to 0.
Yeah, current in R5 equals to 0, correct. Now when does that happen? Is there a relation between the resistors here, R1, R2, R3, R4?
Yeah, when R1 and R4 equal to R2, R3.
R1, R4 is equal to R2, R3, do you say?
Yes, sir.
Which can equivalently be written as R1 by R2 should be equal to what? R3 by R4, right? So basically the ratio has to be the same, right? The resistors here, they have to be in the same ratio, correct? Am I right? If that happens, these two potentials here, let's call it V1 and V2, these two potentials here will be exactly same, right? And there will be no potential difference. So that is why the current I will be 0 here, right? So it doesn't matter even if you remove this connection, nothing will change, correct? Fine. So now let's consider the case here. It is actually slightly, I mean, other than this, if this had not been here, if the upper part, the one which I just darkened with the highlighter, if that had not been here, would it be a perfect Wheatstone bridge, a balanced Wheatstone bridge?
Yes, sir.
Yes, right?
Yes,
It would be a
yes.
perfect Wheatstone bridge, right? So now, if it will be a Wheatstone bridge, now what about this point and this point? They will be at the same potential, right?
Yes, sir.
Now, if it is a Wheatstone bridge, ignore the part highlighted with the green highlighter. Okay. Other than that, whatever is not highlighted, that is a perfect Wheatstone bridge, right?
Yes,
Now,
sir.
what I'm saying is, if that part is not there, the part which I just highlighted, okay, if that part is not present here, so, or let me not just say, let me also write it here. That makes, so ignore the green part. So the circuit will be like this, right? It will be 3 ohms here, 3 ohms here, and then you will be having a 2 ohm here, and sorry, 2 ohm here, right? And there will be a voltage source here, and you have this 2 ohm resistor in between, right? So now I'm saying is, this is a Wheatstone bridge, right? This is a very balanced Wheatstone bridge, isn't it? In that scenario, this potential and this potential here, they have to be exactly same, right? V1 and V2 here, they have to be exactly same, or let's not do that naming, let's call it V2 and V3. Okay, in that case V2 will be equal to V3, right? Isn't it? V2 will be equal to V3 if you ignore the green part for now, and the circuit is only this much, the one that I've just drawn below. Come on guys, give me any response, otherwise I feel like I'm talking to
Yes, sir.
myself.
Yes, sir.
Yeah,
Yes, sir.
fine. So this is a perfect Wheatstone bridge. In that case, the voltage V2 and V3 will be exactly same, right? So even if you remove this 2 ohm resistor, doesn't matter, right? Because no current will be flowing through it. Huh?
Yes, sir.
Correct. Now let me ask you this again. That yeah, fine. Now even if I add a third branch, sorry. So now let me remove this. Let me add a second. Let me add an extra branch here. So the condition is add the green part. So it will be what? This is 3 ohms again. I'll just copy it. Okay. And on the top of it, this 6 ohm. Right. Then this is again what? This is again 6 ohm. Fine. And this is V2. We have a how much? 3 ohm resistor in between. Placed here. So this is V1. Alright. So now tell me what even now if I add this condition, even when I add an extra branch here, tell me does it imbalance the already perfectly balanced Wheatstone bridge?
Same.
So it will be much better if I remove this 3 ohm resistor. Tell me if I remove the 3 ohm resistor, comment on the voltage V1, V2 and V3. Will they be same or will they be different? So
Same.
following would help. So let's call this was what, 6 volts, right? This was 6 volts. So tell me what will be the voltage V1 here? Come on guys, this is classic voltage division. What is this? What will be 6 voltage V1 here?
6 volt.
Will it be 6 volts or will it be 3 volts? So this is the voltage V1 right here. So 6 volt will divide equally between these two resistors, right? Because they are in series, isn't it?
Sir.
So 3 volts will drop here and 3 volts will drop here. So V1 has to be equal to 3 volts, right? This is a different color. So V1 has to be equal to 3 volts, correct? Same way, tell me what will be V2?
Same 3 volts.
Same, sir.
3 volts. And V3 will be also 3 volts, correct? So this is the condition when you remove when I remove the resistor 3 of this resistor, this particular resistor, 3 ohm resistor. Now even if I add this resistor here of 3 ohms, will anything change?
No, sir.
Nothing will change, right? because it was an already balanced Wheatstone bridge to start with, right? If in this particular scenario here, this particular circuit here, these resistors which are put here in the middle, they have no job. No, they don't contribute to anything because it's a very perfectly well balanced Wheatstone bridge. All the branches are perfectly balanced. That is why the voltages V1, V2 and V3 will all be same, and you can remove the resistor which is placed in between them. Okay. So if that is the condition, now can you comment what is the current here? The current I. This was the current, right? This is what you have to find out. Current I. So tell me what will be the current here. So it's a simple simple parallel combination, right? You have 3 ohms here, you have 3 ohms here, you have 6 ohms here, you have 6 ohms here, and you have 2 ohms here, and again you have 2 ohms here.
It has to be 3 amps, sir.
Come again?
3 amps, sir.
Yeah. Let's write it out first. Let us do it. It is 6 volts. So what will be the series combination? It will be 2 plus 2 is 4, 3 plus 3 is 6, and 6 plus 6 is 12. So it is basically how much? 1 over. So overall R equivalent is what? What is the equivalent resistance?
2 ohms, sir.
Is it?
Yes,
So
sir.
it is 1 over 4 plus 1 over 6 plus 1 over 12 inverse, right? So how much is it? 3 plus 2 plus 1 divided by 12, which is equal to 2 ohms, correct? Yes. So the correct answer is what? I should be equal to 6 volt upon 2 ohms, right? Equal to 3 amperes. So you understood this problem, right? This was nothing but all the crazy structure that is drawn here was just to confuse you. I mean, you can easily draw it in another manner, another fashion, and you will. I mean, I just drew it in this manner, and it was very easy to look at it from the perspective of Wheatstone bridge, right?
Sir,
We have all been.
Sir,
Yeah.
excuse me, sir.
Yeah.
Sir, we can solve this problem with the help of star delta.
Star delta.
Yes, sir. That would be more easy, sir.
Yeah, but that is not covered, right? I mean, I will not be. I cannot talk about something which is completely out of the scope of this thing, right? I mean, star delta is not even taught in this course, so I cannot go in that direction.
Okay, okay.
Definitely, yes, you can use that, but this is not something which I can cover because this is not even touched in this particular course. This is way outside of the scope of this course. I can only talk about things which, in fact, Wheatstone bridge is something which is again not talked about in this course, but since it is something which is already known to everyone who has gone through high school, I simply touched this. This question could, however, be solved in classic manner by simply taking KCL and KVL, right? You could have solved it using KCL and KVL. However, that would have been much more cumbersome because a lot of equations you will have to solve. So anyway, so you understood the point of this problem. So never get I mean, discouraged seeing a very complicated kind of circuit. It is just to confuse you. You can easily draw it in another manner, and then it will be easily reducible to a very classic form. Okay. Fine. So
Yes.
if that is clear, let's move on to the next problem. Yeah, Asif, you have a question?
Yes, sir. I have a question.
Yeah.
It is about the Wheatstone bridge, sir. What we have learned in the school is that the load balancing is between a single bridge. But here, what you have explained is about two bridges and
Yeah.
the balancing.
Correct.
That's
Correct.
somewhat confusing.
Correct. So that is why I started with a condition that I said that basically you can ignore the green part for time being. Okay, I said first ignore the green part. Then it's a classic Wheatstone bridge, right? It's a simple two branches, right?
Okay.
If you
sir,
ignore
okay.
the green part, then it's a simple two branch here, right? In that you see it's perfectly balanced, correct? Now
Yes.
even if you extend it, so a Wheatstone bridge can never be disturbed if you keep on extending similarly balanced branches. Okay, it will not be disturbed. Okay, so
That is also.
yeah, it doesn't matter even if you add another branch here. Okay, and if that is also balanced in the same ratio, it will again not matter. Okay,
Okay, sir.
yeah, so that
Got
was
it,
the
sir.
whole point. Correct. So now let's move on to the next question. Okay, so this problem is about capacitors. So you have also learned about capacitors in the in this week, right? In this week's tutorial, not tutorial, but lecture material. So the question asked here is the charging time required to charge the equivalent capacitance between the given terminals A to B to 100 volts by a steady direct current of constant magnitude of 10 amperes is. So what is the scene here is that between this terminals A and B, okay, you have got some equivalent capacitance, okay, and it is being charged using a constant current source of 10 amperes. So tell me what will be the, I mean, how long will it take to raise the potential of potential difference between A and B to 100 volts? That is the question. Okay, tell me what should I do? And this is kind of a revision of standard 12th physics. There you learnt about what happens when you put capacitors in parallel series, what happens to resistors in parallel and series, and what happens to inductors also in series and parallel combination. So tell me what will be the condition here? Tell me how should I proceed? Someone please volunteer.
Calculating the equivalent resistance, capacitance, I mean.
Yeah, correct. We have to calculate the equivalent capacitance between this node and this node. So how should I do that? I mean, where should I start?
Start at the
5
extreme.
Yeah, come again.
Start at the extreme ends of 3 and 5.
Correct. So what do you think 3 and 5 are in?
8, sir. Both will add.
Correct. Both will add because they are in parallel, right? So let's do this. So first of all, what will we do? What will we do? In the first step, we have what 3 micro and 5 microfarad in parallel, right? So their equivalent capacitance is what? 8 microfarad, right? Correct. So the 3 and 5 microfarad can be replaced by an equivalent 8 microfarad in between these two terminals, right? Correct. And you
Yes.
can ignore this in that case. You can ignore this too. Okay. Fine. Come now, tell me what happens. Now you have the following network. This is 8 microfarad. This is 8 microfarad. This is 4 microfarad. This is 8 microfarad. What should I do now?
8, both 8 in parallel, sir.
Both it in parallel or both it in series? What
I
do you
mean,
think?
they are in series, so the
Yes.
equivalent has to be parallel.
Correct. Equivalent has to be
In parallel.
parallel to what? I mean, first of all, what will be the equivalent of 8 and 8?
4, 4 mic.
Yes. Yes. So
Yes.
you have 8 microfarad and 8 microfarad in series, right? So their equivalent capacitance will be how much? 4 microfarad. And what will be this in parallel with? It will be in parallel with
4
4
microfarad.
microfarad.
4 micro.
4 microfarad. So it will be like this, right? Sorry, this is.
Will be 8
Oh,
microfarad.
it's not a resistor, it's a capacitor. So, sorry. Uh, so it's a 4 microfarad capacitor, right? And now you can ignore these two, correct? Now the network is only
Yes.
how much? Only here, correct? Now tell me what should I do now? Now tell me what should I do?
4 and 4
Parallel, sir.
microfarad are in parallel. So
Correct.
they'll
So
add up to 8 microfarad.
correct. 4 microfarad and 4 microfarad are in
parallel, sir. 4 microfarad in parallel in 4 microfarad. This is
So
8
that is
microfarad.
correct. This is 8 microfarad. Definitely yes. So now this 8 microfarad will be placed where? Where should I place this 8 microfarad?
In parallel
A and
with 8
B?
microfarad.
Definitely yes.
Then 4 microfarad.
Definitely. Now we can ignore this also, right? Oh, what am I? Now we can ignore this also,
Yes, sir.
and the equivalent is now only this much, right? The circuit. So 8 and 8 in parallel will be what? It will be
4
16, right?
15 microfarad.
16,
Yes.
yes, sir.
So 8 microfarad and 8 microfarad in
16.
parallel. So the equivalent capacitance is 16 microfarad, right?
Yes.
And where will it be placed? So tell me what will be the
Between
equivalent
A
circuit? It will be like this, right? How much should this capacitor be?
16 microfarad, sir.
Yes. Yeah. Now what is the question? The question is that how long will it take for the potential difference between A and B to rise to 100 volts if it's starting with 0? At the very start it was 0, right? How long will it take for the potential difference VA minus VB to rise to 100 volts? Tell me, what should I do? First of all, why is this question asked? I mean, what happens when a capacitor is what happens when this constant current source is connected like this with a capacitor? What will happen? What do you think should happen? Start happening?
The initial finally open circuit.
What happens? Okay, what is the
short circuit and finally open circuit?
Okay, so that is something which is okay. You're confusing now. Okay, so let's not delve into open and short. Tell me what is the characteristic equation of a capacitor? I mean, what is the capacitor identified with?
I is equal to C into
Exponentially,
dV by
Q is
dt.
equal to C into V, right? The charge across a capacitor is the charge stored on the capacitor is basically a function, or it is basically proportional to the voltage across it, right?
Yes, sir.
Correct. So, I mean, if you have a capacitor here, in that case, the voltage that is between that is across its plates, and the current and the charge that will be here will actually be related to each other, right? They are proportional to each other, and that proportionality constant is what we call as the capacitance, right? So, what will be the current? It will be dq upon dt, which will be equal to C dV by dt. Correct?
Yes.
Yeah. So, what is the assumption here, by the way, when I write this? When I move from here to here, what is the assumption? First of all, what did I do here? I simply differentiated with respect to time, right? I found the derivative of this equation with respect to time, both sides, right? I did that, isn't it?
Yes,
So
sir.
what did I assume here when I wrote this?
C is fixed capacity.
Correct, definitely yes. Otherwise, there would have been this term also, V into dC upon dt. Okay. So here we assume that the capacitor is fixed. So derivative of capacitance with respect to time will be 0. Okay, so I didn't write this because we assume that C is fixed. All right, so as long as we are clear on that, so current is equal to what? C into dV upon dt. The current that is going to flow in this direction, okay, that will be C dV by dt. So now you have the similar situation here. A 10 ampere current source is flowing here. The current I here is 10 amperes and it is flowing onto this capacitor. So tell me what will be the equation here? Go on, tell me what will be the equation here? Okay, don't give me the answer directly. Tell me what will be the equation here first. Okay, so Asif, since you have written the answer on in the chat box, so can you please tell me what will be the equation here?
Sir, I have used integral method, sir.
Yeah, so tell me what will be the equation here?
In applying integral on both sides, sir?
Yeah, so tell me now what how did you apply integral? What equation did you write?
It is V is equal to 1 by C integral of
V is
I
equal
dt,
to,
sir.
so is it VAB, right? VAB is
Yes,
equal
sir.
to 1 over C integral I
0 to T I dt
dt 0 to
with limits T, sir.
T, correct?
Yes.
Correct, definitely. So this is what you will get. So let me write it in differential equation function. It will be what? It will be C into dVAB upon dt will be equal to what? Equal to I. Okay. And since I is equal to 10 amperes, so it will be like this. So this was a digression. So let me take it here, put it here, and put a box around it. This is a digression. Fine. So we have what? DAB is equal to 1 over C 0 to T, and I is what? 10 amperes, correct? 10 dt. So since 10 is a constant, dt integral will be what?
10 T, sir.
Correct? Into 10, right? And what is the voltage VAB supposed to be? 100 volts, right?
100 volts.
Correct. So it's 100 volts will be equal to 1 over C into T into 10. So everyone is everyone following this?
Yes, sir.
Yeah, since this is very basic stuff, so I'm not going into I mean extreme details or minute details of it. I'm assuming you are all following this. So time will be what? 100 times C divided by 10 will be equal to what? Oh, by the way, this, yeah, this is how much?
160 microseconds.
160 microseconds.
10 into 16 micro, right? Will be equal to what? 160 microseconds, correct? So the first one is the correct answer here, right? This is the correct answer. Fine?
Yes, sir.
Yes.
So the purpose of this question was to make you comfortable with the series and parallel combination or reduction of a capacitor network, okay, and then be able to apply general differential equation for a capacitor, right? So you are comfortable with a simple, very simple network which involves capacitors now, and you will be able to solve it. You just have to understand that.
Yes, yes.
Okay.
You just have to be you just have to remember this particular relation here, okay, that a capacitor, this is the characteristic equation of a capacitor. Never forget this. Always keep this in mind and you will never be having any difficulty with capacitors in question, okay. This will help you analyze the transient behavior. I mean, whenever time is involved, use this equation. Fine. So moving on, let's move on to the fourth question. Okay, so this is a slightly complicated one. Before this, let me, yeah, this is much better. Yes, this is much better. So tell me, the question is here, the current and voltage waveforms for an element are shown in the figure. Find the circuit element and its value. So this is a current waveform and this is a voltage waveform across an element. You do not know what is the element, okay? So the element is a black box for you, okay? But you know what is the current profile of it. This is IT and this is what?
मेरा phone जो
This is B of T.
पानी का तो sir.
Please
This
mute
for down
yourself,
है.
whoever is speaking. Please mute yourself, whoever is speaking. Yeah, thank you. Fine. So in this question, you do not know what is the element here, okay? But you know what is the what is its voltage and current waveform look like. When you characterized it in the lab, you saw that this is the current flowing through it, and this is the voltage across it. Okay. So now tell me, what should be the procedure here, and how will I find out what is the element, what kind of an element is this? Is this a resistor, is this a capacitor, is this an inductor, or is this something else? How will I characterize it?
I think this is inductor, sir.
Yeah, so why do you think so?
So because current is slowly increasing and then becomes constant.
Yeah, so I mean, if simply current is increasing, what can you infer, how can you infer anything about it?
At constant current, the voltage is zero. So
At
the
constant
inductor equation
current, the
is V
voltage is
equal.
zero.
Yeah,
Okay,
and
so
the inductor equation is V equal to LdI by dt.
correct. So
So we
basically,
can.
so let's do this. So for a capacitor, we already saw that the characteristic equation is what? C dV upon dt is the current flowing through it, right? So current will only be non-zero when dV by dt is non-zero. Basically, voltage should either increase or decrease or do something else. It cannot be a constant here. Otherwise, the current will be zero, right? For an inductor, what is the equation? L di upon dt is equal to V, right? That means the voltage across an inductor can only be non-zero when the di by dt term is non-zero, right? Or the current should be increasing or decreasing. If the current is constant, then the voltage cannot be non-zero, right? What is the equation for a resistor? V is equal to IR, right? In this, the voltage and current, they are both proportional to each other, right? So if the current is increasing, voltage should also increase. The current is decreasing, voltage should also decrease, right? I mean, neither of them can go independently, right? The one has to be like, if one increases, other one also has to increase. If one increases, the other cannot sit just like that. It cannot keep constant. So in this, you see that when the current is increasing, when the current becomes a constant, the voltage is zero here, right? So as one of you correctly pointed out, this has to be an inductor, because only in an inductor, for constant current, the voltage is zero. And when the voltage is a constant, okay, when the voltage is a constant, what does that mean? If the V is a constant, that means di by dt also has to be a constant, right? Which means the slope has to be a constant. The current versus time slope has to be a constant. So you see here, the current versus time slope is constant, isn't it? It's a straight line. So you are following me, right? Slope is constant here. So that is why it's an inductor. Okay. Now tell me, what will be the value of this inductor? How will you find out what is the value of this inductor? Yeah, Someone, please.
Different.
Integrating on both sides on the LDI by dt equal to V equation.
Do I need to integrate, or is it much easier than that? So see, L di by dt
Find the slope.
is equal to V, right? So I just need to find out di by dt, right? So what is the slope here? Di by dt here.
2 by 25, sir.
Correct. So di by dt is equal to 2 by 25. So this is 2 by 25 into L, which is equal to the voltage here, which is equal to what? 2 volts, right? 2 and 2 gone. So L is equal to what? 25 Henry, right?
Yes.
So this is the correct answer. So is everyone comfortable with this question?
Yes, sir.
Yes, sir.
So there was no difficulty in this question, right? So this particular question is to motivate the experiment. Okay, I mean this is generally when you will be going in the lab, and suppose someone comes to you with a different with a new kind of device, okay, and you want to know what kind of a device it is. So what you will be doing? First you have to characterize it, right? You have to see how it behaves in the presence of a voltage source. I mean, what is its voltage versus current profile, right? That is the first thing which you will be checking as an electrical engineer, right? Yeah. So when someone comes to you with a new device, you first try to characterize it. You first take it, connect it across a a battery, and try to see how it behaves in the presence of a voltage source. I mean, how is its voltage versus current profile? You first check that, and with that information you try to characterize it, whether it is an inductor, capacitor, or a resistor, or transistor, or whatever, right? So this is basically how it is done. You start taking observations. So what is the value of current, then what is the value of voltage, okay, and everything you plot, and then you see what is then you take the graph, and then you try to basically hypothesize that it is this particular element. Okay, so this is how it is normally done. Okay, so the previous question, when I said it is a complicated one, I didn't mean that it is very difficult. I just said that let's proceed with the other questions first, so that I will cover definitely this fourth problem. I will cover it. Okay, I will not be leaving it today. I mean, the whole point of this sessions is that I solve difficult questions. So I wanted to first cover the basics here, so that I cover. After that, I will definitely touch that question. Don't worry. So yeah, so this is a tricky question for you, this problem. So in this problem, you have to find out what is the current I. Tell me. So just to motivate you, questions like this often come in GATE examination. Okay, so tell me, what will be the current here? Am I audible?
Yes, sir.
Yes, sir.
Okay.
Hello.
Fine. So what is the current here?
Hello.
Yeah. Hello. Is someone trying to say something? Anyway, so what is the current here? What should I do? How should I find it out? Come on, guys, tell me something. What should I do here?
Using KVL.
KVL, you say. Tell me where should I use KVL and how should I use? Can you tell me exactly? Okay, so let me tell you why am I saying this question is slightly tricky. Is because you see this this network here. Okay, these two are shorted by a single wire. Okay, these two are shorted by a single wire. So this can equivalently be drawn in this manner. This is a 1 ohm resistance. This is a 3 ohm resistance. I shorted it here. 2 ohm resistance, 9 ohm resistance, like this. Okay, or even slightly better, let me do like this. So one could have drawn it in this manner also, and in that condition there would be no current I here, right? Are you understanding what I am saying?
Yes.
Yeah, so but just to make your life uncomfortable, this question has been framed in this particular manner. So tell me, what is the current I in that case? How will you proceed? Come on, go on. Okay, so since none of you is speaking, so I will have to solve this all by myself. So since I have drawn it here, let me just put it here. Okay, so let's call this as VA. Let's call it VB, or let's put it. Let's call it the reference. Okay, this node as the reference, and let's ground it. So this potential is 0, right? So first of all, tell me what will be the equivalent resistor across this terminal A and B. So this is basically terminal A, this is terminal B. Okay. So what will be the equivalent resistance across terminal AB?
10.
How much?
10.
That doesn't look right. So what is this? 3 and 1 are in parallel, right? These two are in parallel here. These two are in parallel here, these two are in parallel here. And then they both of their equivalent resistance are in series, right? So 1 and 3 are in parallel. So are you following me or not?
105 upon 44, sir.
Okay, let's calculate it. So 1 and 3 are in parallel, so equivalent resistance of that is how much?
3 by 4, sir.
1 parallel 3 will be 3 by 4, definitely, yes. So which is 1 ohm parallel 3 ohm, and this will be equal to 3 by 4 ohms. Then again we have parallel of 2 and 9. So it will be how much?
18 by 11, sir.
18 by 11.
Okay, let's do that. 2 parallel 9, which will be equal to 18 by 11 ohms. Correct? And they are in series. This is A, this is B, and then this is grounded. Okay. Now both are in series. So what will be the equivalent? It will be 3 by 4 plus 18 by 11. So it is equal to, as one of you correctly pointed out, 33 plus 72, right?
Yes, sir. Upon 44.
By 44, which will be equal to 105 by 44. Correct? So this is the equivalent resistance, R equivalent. Fine, that's fine. So now tell me, what will be the voltage at this node? Let's call it VC. Okay, let's call it VC. So this VC here and this node C, this will be exactly same, right? This will also be VC, right? I mean, this terminal will be C. Let's call it the Cth terminal. So tell me, what will be VC here? First of all, what is VA? What is VA?
Ten volts, sir.
10 volts.
Yes, sir.
Correct. VA is equal to 10 volts. Definitely, yes. Let me not cramp it here and put it down. Yeah, fine. So voltage VA is equal to 10 volts. So what is VB? VB is equal to What is VB?
0 volts, sir.
Yes, VB is 0 volts. So why is it taking so long to answer that? VB is equal to 0 volts. Yes. So what is VC? Tell me. What is VC? So this is a simple circuit, right? Tell me, what is VC? So this is the circuit here, right? This is the circuit here. Tell me what is VC? You know already that this node is 10 volts, this is 0 volts. What is VC? You know the resistances value. What is VC? Okay, so let's do this. VA minus VB, sorry, VA minus VC by this particular resistance 3/4 is what is the current flowing here, right? In this direction. Am I correct? What is the current flowing here? I. Come on guys, someone please speak. So the condition is like this, the voltage, the scenario is this. You have one resistance, you have another resistance here. Okay, you have a voltage source here. This is grounded. This is no terminal C, this is terminal A, this is terminal B. You already know that this is 3/4 ohms, this is 18/11, right? 18/11 ohms. And I'm asking, what is the voltage VC here? You already know that VA is 6 volts, sorry 10 volts, and VB is equal to 0 volts. Tell me what will be VC? And what should I do here?
Sir, VA minus VC upon 3/4, and that
VA
will be
minus
equal,
VC upon 3/4 should be
and
equal
that
to
will
what?
VC minus VB by 18/11.
So why did you say that?
The same current will be flowing through the series connection.
Yes, the current here and current here should be same, right?
Yes.
Yeah, fine. So why did it take so long to answer?
Because sir, my mic was not working.
Okay, fine.
I was the one who was saying hello again and again.
Okay, fine. Anyway, so this is the condition. So what will be VC here? And VB is anyway 0, right? So let me as well get rid of it. So VC is equal to what? 18/11 divided by 18/11 plus 3/4, right? Into VA. Correct? So you can do it. It will be exactly like this only. It will come out from here. Okay, if you solve the maths. So what will be VC? It will be 18/11 upon 105/44. So what will that be? 72/105, isn't it? So what will this be? So it will be divisible by 3, right? So 3 2s are 6 and 3 4 12. You have a 3 and then 15. So this is the voltage VC, 24/35. Okay. Oh, sorry. By the way, it will be VA times VA. Yes. 24/35 into 10. So how much will that be? 48/7 volts. Correct? Fine. So now we have found out VC. Right? So we have found out what is VC. Now tell me, what should I do? So we have this network. This is terminal A, this is terminal B, but this is 0, and this is terminal C, and we already know that this is 48 by 7 volts, right? So this is 1 and 3, this is 1 and 3, and this is how much? The other one, 2 and 9 ohm. We have to find out what is the current I here, correct? Tell me, what should I do now? Yeah, go on. Someone, please. The person whose mic just started working, please. Can you help here? What should I do? Alright, so see, in this question, you see that again, try to think of it in this manner. So current here I will be what? You can apply KCL here, right? You can definitely find out what is the current flowing in this branch, right? Because you know the voltage here and you know the voltage here. So you can definitely find out what is the current flowing here. You can also find out what is the current flowing here, right? Now in the same manner, you also know the current flowing here and current flowing here, correct? So you see that only this current is unknown. So you can definitely apply KCL at this node, right? If you apply KCL at this node, you will be able to find out what is the current flowing there. So let's do that. Let's do it. So what is the current here? Tell me. It is, let's call it I1, okay? And the current here, let's call it I2, okay? Fine. So tell me, what is I1? What is I1?
3.4.
3.39.
10 volt minus 48. Don't give me the answer directly. Tell me, I mean, how to find out. I mean, that is what I mean when I ask you what will be the current. Tell me how to find out.
VA minus VC divided by 1 ohms.
Yes, divided by 1 ohms. So it will be 70 minus 48 upon 7, right? How much will it be? It will be 22. No, sorry.
No. Around 3.39 or 4.
22 by 7. Correct? Am I right? Is this correct?
Yes, sir.
Yeah. So what is I2? I2 will be 48 by 7 minus 0 upon
minus 0 divided by 2 ohms.
2 ohms, right? It will be 24 by 7, right? So this is basically VA minus this is VA minus VC, right? Divided by 1 ohm, and this is what? VC minus VB, right? Fine. There is 24 by 7 amperes. All these are in amperes, correct? Fine. So now you have current which is coming in this direction here and it is leaving this node here. So what will be the KCL here at this node? Come on, tell me what will be the KCL here?
It's I1 plus I equal to I2, sir.
Yeah, let's write it. KCL at this node, it should be equal to I1 should be equal, sorry, I1 plus I should be equal to what? I2, correct? So what is I1? 22 by 7 plus I we do not know, and I2 is 24 by 7. Correct. So what is I? 24 by 7 minus 22 by 7, which is equal to 2 by 7 amperes. Correct. So how much that is that? 0.2, right?
0.28.
8, and then anything else? What is 2 by 7? 0.8 something, right?
Correct one.
0.2857, right? Something like that, amperes. So yeah, so here is an answer, 0.29. Correct. So 0.29 is the correct answer. 0.2857, it can be approximately written as 0.29, right? So 0.29
Yes,
is
sir.
the correct answer. So everyone, did you understand what I did in this question? I mean, why did I call this question as tricky? It's because there is no significance of asking this problem. I mean, this current I, there is no significance in that manner. It's just a it's just the manner of connection that you did. Okay. If we connect it in this manner, then there is a current flowing here. If you connected it in another manner, then there was no current here. Okay. It's just how you connected it. It mattered. This is slightly tricky, and people often make mistakes in this kind of questions. So this was very easy. You will get the same answer even if you apply KCL in these two particular branches and this node here. Okay, even if you apply KCL in this node at this node here, you will get the same answer. Okay.
Sure, sir.
Yeah, fine. So no one has any doubt in this question, right? I'll move on. Okay, this is also a very important question. This is kind of very easy. Tell me what is the so the question is like this: the two electrical networks N1 and N2 are connected through 3 resistors as shown in the figure below. The voltage Vx across 3 ohm resistor is what? So you have one network in this here and one network here, and both of these networks, these two networks are separate, okay, but both of these networks, they are connected via 3 different resistors here. One is 2 ohm resistor, one is 4 ohm resistor, and another one is 3 ohm resistor. So now you know what is the voltage across this 2 ohm resistor. This is 6 volts. Across 4 ohm is 16 volts, but you do not know what is the voltage across this across the 3 ohm resistor, and you are aiming to find it out, right? So tell me, what should I do here?
6 by
We
2
can
plus.
apply KCL.
Yes, exactly. So how should I apply KCL here?
Sir, 6 by 2 plus 16 by 4 plus Vx by 3 equal to 0.
Why did you say? So don't okay, so it's my advice to all of you. So it seems that is only the that can only be a way in which you can find the answer in this question, and it turns out that is actually the correct whatever you said is actually correct. But this is my advice to you, that don't just blindly try to solve the question. Try to reason, try to question yourself. Why are you doing what you are doing? So you said KCL is the correct approach here, okay, but when you said KCL, after that you said that 6 by 2 plus 16 by 4 plus Vx by 3 should be equal to 0. Now why should that be the case? Why should that happen? Try to question this and try to satisfy yourself with the answer. Try to find a definitive answer that will help you all the times. As an engineer, as a even in the interviews, it will help you. This habit of questioning yourself before finding the answer, before jumping to answer, you will, if you question yourself and if you reason yourself, then you will never find any problems along the way. This is a very good practice actually. Yeah, Asif, you have a question?
Sir, can we consider N1 as node and apply KCL? The answer to his reason, to his answer?
Why should you consider N1 as node?
That's a network, so.
Yeah, so tell me, why should I consider N1 as a node. So if you are saying that, why don't I replace N1 with a node like this, right? This is N1, and then this is N2, and then we have 3 different connections here and there, and that is what you're saying, right?
Yes, sir.
And to that, my question is, why should I do that?
Sorry, sir.
Sir,
Yeah.
sir, I think we should apply KCL because current coming and current leaving from the network should be.
Yeah. So see, what you should do is you consider everything as a whole. Okay. Sorry. You should consider all of this as a whole network. Okay. And now try to imagine this. In this network, the sum of all the current should be equal to 0, right?
Yes, sir.
The answer is minus 21 volt.
Yes, answer is minus 21 volt. But did you understand the reasoning behind it? If you consider the whole network, everything inside a giant box, then everything, all the current should add up to 0, right? That has to happen, right? Because the currents cannot, I mean, whatever current cannot come out of nowhere, right? It has to be, the sum of all the current should be 0, right? Otherwise charges will start building up inside this particular box. That is not possible, right? And whatever Asif you said also, that is also fine. I mean, that is also fine. This can be considered as a node.
Okay, sir.
Yeah, so you were right, but I just wanted to get the reasoning behind it. This is what actually has been taught to you also in the lecture, I guess. 2 different networks, and if they are connected like that, then what happens? So this is basically, you have to consider it as a giant network, N1, N2, and connected by these 3 nets. You consider it as a giant network, and in that case, the sum of all the currents should be 0. Correct?
Yes.
So that is why the current here will be what? 6 by 2 plus 16 by 4 plus Vx by 3 should be equal to 0. 6 by 2 plus 16 by 4 plus Vx by 3 should be equal to 0 by KCL, right? So what is the Vx is equal to minus 21 volts. So actually this is correct. Fine.
Yes, sir.
Yeah. Cool. So let's move on. What is the time? 5:31. All right. Okay. Come on. This is also an interesting question. So how many of you have solved S.C. Verma's book on physics in standard 12 and 11? I think all of you must have solved that. I mean, most of you would have solved that particular book. So whoever didn't solve, I don't know. Means it is quite famous book for standard 12 physics. So I solved it when I was in standard 11 and 12. Anyway, so this kind of question was there in that book. So tell me, so what is find VB minus VA? That is the question. So VB is this one and VA is this one. Sorry, it's the other way. It's VA here and it's VB here. So you are asked to find what is VB minus VA. Tell me, what should I do?
The first find VA.
What?
So first of all, we find VA.
Yeah, correct. So what is VA? How will you find it out?
Using current division.
Current division. So current here, 24 microamperes, 24 ampere current is coming. It will divide here and here. You're saying, right? So what did you mean when you said current division? Which current division are you talking about? Yeah. Go on. Am I audible?
Audible.
Hello? Yeah.
Audible.
Yeah, fine. So tell me. Come on, guys. There's so much silence here. Tell me, what should I do? Okay, what is VA? How will you find out VA?
45 volts, sir.
How did you come up with that? Why is it 45 volts?
With the help of source conversion method, sir. Current source converted into voltage source.
Okay. Okay. That is fine. So since that is not covered till now, could you please... Okay, so in that case, I cannot talk about that because that is not covered till now. So any other way you would like to discuss this?
Sir, using current division.
Where? That is what I asked earlier.
That 15 ampere current will be flowing from 3 ohm resistor.
Okay, 15 ampere you said.
And 9 ampere from 5 ohm resistor.
Okay, 15 amperes here and then 9 amperes here you are saying. Okay, so what will that? So that is why it is 9 5s are 45 you are saying. 45 volts you are saying. That is why you are saying it is 45 volts, right?
Yes, sir.
So but when you said VA is equal to 45 volts, it means that you inherently assume that this node is what? Grounded, right?
Yes.
Didn't you assume that?
Yes, sir.
Yeah, so you have to be very specific about that. I mean, the whole point of this question is to basically confuse you with that. If you are not very careful with the ground, where you place the ground, you are going to struggle in this question. Okay, fine. So this is ground. The moment I put this node at ground, this whole net here completely it becomes 0, right? The voltage here becomes 0, and then with respect to this 0, the voltage at this node is 45 volts, right? This 45 volts can also be found out in this manner. So this 3 and 5 they are in parallel, right?
Yes, sir.
So 3 and 5 are in parallel. So that is why the equivalent resistance will be what? 3 into 5 upon 3 plus 5, which will equal to 15 by 8. Correct? And in this 15 by 8 ohms, a current of 24 ampere is flowing. Correct? So the voltage will be what? VA will be 15 by 8 multiplied by the current. So it is 45 volts. Fine?
Yes.
Fine. Now that we are clear on this voltage, now tell me how to find out VB.
To 6 volts, sir.
How much?
6 volt.
6 volt you are saying? How did you come up with that? Okay, what is the current flowing here?
2 ampere, sir.
No. One minute. Let me tell you where. So what is the current flowing here?
Zeros.
Why did you say 0? Why is it 0? Yeah, so as I just said, I like this particular question, this y, okay, WHY. I like this very much. So whenever I ask you something, you answer me, I will immediately ask you why. So think before
It has
answering.
to satisfy.
So
It has
first
to
and second.
satisfy KCL, sir.
It has to satisfy KCL, definitely, yes. So what?
So there was a current. It has to leave from somewhere.
It has to leave from somewhere, you're saying?
Yes, sir.
Yeah. So let me. So this current I is connected with is going to, if at all, if it is flowing, if it is non-zero, it will contribute to currents at this node and at this node, right?
Yes, sir.
So let's try to find out what happens. So if this current is non-zero, then the current here coming here and current coming here and this current I. So basically let's call this, okay, so maybe I do not need to write so much. If this current I is non-zero, then this current and this current, they have to be different, right? Let's call it I1 and let's call it I2. If I is non-zero, then I1 will never be equal to I2, isn't it? If I is non-zero, I1 can never be equal to I2.
Yes.
Is that okay?
Yes, sir. Yes.
Is that okay with everyone? So let me write it. I mean, I don't know whether it is. So see, you see, so basically at this node, if you write KCL at this node, so KCL at this node is what? I1 should be equal to I plus I2, correct?
Yes, sir.
So if I is non-zero, in that case I1 can never be equal to I2, don't you think?
Yes, sir.
Right? So if I1 is not equal to I2, what will happen? What will end up happening? So this will become much more clear when you reduce it into its equivalent form. So what will be the equivalent this thing? This will be 24 amperes and the equivalent resistance was what? 15 by 8 ohms, right? This was 15 by 8. Sorry. This is my 6 ohms, this is 3 ohms, this is 18 volts. Okay, this is VB, this is VA, and I'm saying now let's call this current as I1, and this is I2, and this as I. Okay, and now again let's try to write KCL here at this node. So KCL here at this node would be what? I1 should be equal to I plus I2, right? And again in this case I1 will never be equal to I2 if I is not equal to 0, correct? Am I right?
Yes, sir.
Right. Now what will happen if I1 is not equal to I2? Why is that a problem? So now tell me, if this I2 is flowing here, the same I2 should flow here, right? This should also be equal to I2, isn't it?
Yes.
And if this is equal to I2, so this also has to be equal to I2, isn't it?
Yes, sir.
So if this is equal to I2, this also has to be equal to I2, isn't it?
Yes, sir.
And if this is equal to I2 and this also equals I1, in that case there is only one possibility, that I2 has to be equal to I1, isn't it?
Yes, sir.
So I has to be equal to 0, isn't it? There can be no current flowing in this direction, in this particular branch, correct?
Yes, sir.
Yeah. So anyway, you must know that from a closed this thing, if only one wire is coming out, if this is a universe, okay, and if this is completely closed and only one wire is coming out, if there is only one wire coming out, it can never contain and it is connected to some other universe, there can be never a current flow in this particular branch. There has to be another wire also. There has to be two wire. I mean, there has to be a closed path for the current to flow. Okay. So you see that this is one universe here. This is another universe here. They have a connection in between, but that connection is only a single wire. So that is why it can never contain any current. Okay.
Yes.
Fine. Now that is fine. So now tell me what will be VB. Now that we are clear on that, and we already know this is ground. Okay, so coming back to this figure only. This was ground, right? We grounded it, and this is 45 volts. This is grounded 0. This current is 0. I is equal to 0 here. So what is this voltage here? Come on, guys. Shouldn't take so much time. This is ground here. This is 0 volts. There is a voltage source placed here of 8 volt. So what is the voltage here?
8 volts, sir?
Yes, this is 8 volts exactly. This is 8 volts. Fine. Now if this is 8 volt at this node, okay, tell me what is VB?
So I can't see your board, sir. I mean, the part which is being explained.
Oh, sorry.
Your
bad.
screen is silent.
Is my screen moving now?
Yes. Yeah.
Okay, cool. So I was asking, I'm saying this is 8 volts, okay, and this is VB. So what is VB? I'm talking about this particular network now. So what is VB?
$26.
How much?
10 volts, sir. 10 volts.
No, I'm getting all kinds of answers here. Okay, so I'll have to solve it. Okay.
10 and 8.
Okay, fine. So let's call it network 1. Let's call it network 1. Let's call it network number 2. Okay. So since we are already clear on network 1, and we also know that there can be no current between network 1 and network 2, so I'll as well get rid of network 1 while I'm focusing on network 2. So please, someone whoever is not unmute, please mute yourself. There's a lot of noise there. Yeah, so I was saying that since we have already established that there can be no current exchange between network 1 and network 2, I may as well get rid of network 1 when I'm considering network 2. Okay, so let me circuit. So I have a this is grounded, this is 8 volts, fine. So this is VB. Now tell me what is VB. So let's solve this circuit, right? So this is 8 volts, right? So let's solve KVL. Let's write KVL in this particular circuit, in this particular loop here, KVL. Okay. Is it fine?
Yes.
Hello.
Yes, sir. Yes, sir. Yes, sir.
So tell me, what will be the KVL here? Tell me. What will be the KVL here?
Eight plus 18 plus.
Yeah, let me start from here, right? So 8 volt, then
Plus
I'm
18 on
moving
potential
plus
raise.
18, correct. Plus 18 volts because I'm moving from a lower potential to a higher potential, isn't it? So plus 18 volts. Fine. Now I'm here. Now from here to here,
I don't know the current, right?
yeah, you don't know the current. So that is why you have to assume for writing any KVL, you know that you have to assume a current in the loop, right? So the current, let it be I.
Yes, sir.
Okay. Now tell me.
Minus 6i.
Minus 6i.
Then VB.
Yeah, I am at VB now, correct.
Right,
Then
right, VB.
so you are saying minus 6i minus VB.
No, no. 1 month only.
I am at this node now. Okay, I am the moment you wrote plus 18 volt minus 6i plus 18 volt, I was here at this node, at this potential here. Then when you subtracted minus 6i, I am at this potential now. Now what should I do? I have to complete the loop, right?
Yes.
So
Minus 6i.
correct, minus 6i, yes. After that,
Minus 3i.
minus 3i, yes. And what will be
Equals
this
to
equal
0.
to? Correct, it should be equal to 0. Okay, so by the way, when I wrote when I said this, is it equal to 0, by the way?
VB equal to VB.
VB, sure. So what did I write? I started at this.
Minus 18.
One second.
It's a closed loop, so it should be 0.
Okay, so let me ask you again like this. So I started at this node. Oh, sorry, I started at this node here. So I wrote 8 volts. The potential, absolute potential of this node I wrote as 8 volt. Okay. Then I moved. So this node was all the same, right? The potential was same here. Then I moved from here to here, and then I said that I have a potential rise of 18 volts, right? Then I came to here. From there I said that a current I is flowing through a 6 ohm resistor, so I have a potential drop across the resistor, which is equal to 6i minus 6i. So that is why then I reach VB, correct? And after reaching VB, I again said that again the same current I is flowing through this 3 ohm resistor, so again I have a potential drop, correct?
Okay.
So the potential drop was what? It was 3i only, right? So when I complete this loop, I reach again at the same potential, right? As at 8 volts. Someone please mute yourself. I mean, there's a lot of noise. Yeah, fine. So fine. So I was saying that this whole while traversing the whole loop, I started at 8 volt potential at this node, and I reached again the same potential at 8 volts. So this should actually be equal to 8 volts, isn't it?
So should we not consider 8 volt then?
If we do not consider 8 volt, okay, so let's say you do not want to I didn't get your question. So what do you say when you say that you do not want to consider 8 volts?
Just to follow KVL, sir. That's
yeah, I'm following KVL, right? I'm saying that I have started at a particular node. What does KVL say? It says that the basically the voltage drop across a loop should be equal to 0, isn't it? When you start at a node and when you come back at the same node, actually you have not lost any voltage, right? Voltage drop is 0, right? if you start at this node and you again come back at this, if you start at this node and then you traverse the whole loop and came back at the same node, absolute potential drop is 0, right? You have not lost any potential. You again come back the same place, come back at the same place. So that is why when you started at 8 volts, then you have again reached again at the same 8 volt only here. That is what I am saying. If you want to, if that is confusing for you, then you can also understand KVL in this manner, that the potential drop across the whole loop is actually equal to 0. If you think about it in that manner, then this 8 volt is not necessary here. Then you can actually write 0 here. Is that understood what I am saying? Is that confusing?
Yes, sir.
This is easy, sir.
Hearing.
Yeah. Okay, fine.
Easy to understand.
Yeah. So what I'm saying is that this 8 volt is an absolute potential of that particular node. Okay, you need not consider it because you are only bothered about the potential drops, right? So you just have to consider potential drop across elements. So you see at in this particular branch here, okay, the potential drop is 0, right? So while moving from here to here, there was no potential drop, so it was 0, correct? Then from here to here, you have a potential gain of 18 volts, so that you have to add here. And then again from here to here, you have a minus 6i drop, right? Then from here to again coming back to here, you have a 3i. And when you do that, you have completed the whole loop. And you also know that in the whole loop, the potential drop has to be 0. So that is why it is 0. Is that clear?
Yes, sir.
Yeah, fine. So whatever suits you. Fine. So this is the KVL here. So what is the current I? 2 amperes, right? Right.
Yes, sir.
Yeah, it is 2 amperes. So tell me what will be VB minus, so if the current I is 2 amperes and this current I is flowing in this direction in 3 ohm resistor, yeah, and this current I is flowing here, right? So tell me what is now can you tell me how to find out VB?
Sir, 18 minus VB by 6.
18 minus VB by 6. Why is it 18 minus VB by 6?
6 volts, sir.
VB minus 8 by 3.
VB minus 8 by 3 is equal to what?
2.
2, correct. So what did I do here? I simply, so see, you have this potential, you want to know what is the absolute value of this potential here, VB, and you also but you know all the other parameters like the current which is going to flow through this 3 ohm resistor. You also know the potential at the other node of the 3 ohm resistor, right? So across a terminal, you want to find out what is this particular value. You have this particular this as 8 volts. You know the current flowing through this resistor. You know the resistor value. So this VB is simply like easy, right? VB minus 8 by 3 is equal to 2. Simple. This is the property of the resistor, right? So what will be VB here? Correct? Sorry.
Sir, 14.
Right?
Yeah, right.
So now VB is equal to 14 volts. So VB is equal to 14 volts and VA was equal to 45 volts. So what is VB minus VA? VB minus VA is what? This is 14 volt, this is 45 volts. So what is VB minus VA?
Minus 30.
31 volts.
It's 31.
Right. So this is the correct answer, isn't it? Right?
Yes, sir.
Okay, fine. So now let's not bother with this. Okay. Maybe I will just solve this. So this problem was one which I told that it is slightly tricky. No, this will has to hold. Before that, this is one last thing which I want to discuss. This is kind of important for your next for this fixed assignment. So you all understood what is mutual inductance, right? So kindly, so this is a humble request to all of you, whoever is attending. Please try to make sure at your end that the noise is as low as possible, right? When you unmute yourself, you try to answer something. If there's a lot of noise in the background, it becomes very difficult for other people to hear, or even for me to hear what you are saying. So please try to ensure that at your end, so that these sessions can be held smoothly. Fine. So yeah, I was talking about mutual inductance. Fine. So you've all learned about mutual inductance in this particular week, right? The week 1. So you have learned that mutual inductor is always associated with a sign, right? So if this is the sign here, so what should be the voltage and current directions which I will have to take? Now go on, someone. Okay, so this will be I1.
Both the currents move
V1. This will
towards
be I2. This will be V2, isn't it? This will be M. Correct? This will be L1. This will be L2. Right? And the equation will be what? V1 will be equal to L1 times
I1
di1 by d2 dt plus M times
di2 by dt.
di2 by dt. Fine. And V2 will be what? M times di1 by dt plus L2 times di2 by dt. Right? This is what it is.
Yes.
Fine. Now you also learned about other cases like that, like the condition where if the situation is slightly different, that if this is here and this is here, okay, what should be your current and voltage directions in that condition?
Negative of it.
I mean, in which direction should the voltage and current should be chosen so as to make it positive?
So mutual inductance at I2 will be negative.
No. So that is not what I'm asking. Okay. So you are saying that if I2 is this way and voltage is this way, then it will be negative, right?
Correct, sir.
So what will be the equation, by the way, in that case? V1 will be equal to L1 di1 by dt minus M times di2 by dt. V2 will be equal to minus M times di1 by dt plus L2 times di2 by dt. Right? Now I'm saying, what do you have to do to make sure that this particular term becomes positive here in both the equation? What should you do?
Reverse the current.
Correct. If you reverse the current here and also reverse the voltage, then this will be fine, isn't it?
Right, sir.
So if you simply reverse the current, what is the problem? You first told that only reverse the current. If you simply only reverse the current, what is going to be the problem? Tell me. What will happen? So let's first think about this particular. So first equation, V1. So what will be the, if this is the condition, if the current direction is the one that is shown in red, what will be the equation for V1? V1 will be equal to L1 di1 by dt. There is no problem there, right? The first term is perfectly fine because that is the self-inductance property. Okay. Now what about the second term? Minus m times di2 by dt. So should it be minus m or plus m?
Sir, as the direction of the current has reversed, so maybe it must become positive.
Correct. It should be positive. Okay. Fine. Now what about the second one, V2? In that, what is this? Minus m times di1 by dt. So what should it be? Should it be minus m or plus m?
Plus.
You are saying it should be plus m. Okay, let's do that. And why did you say it should be plus m?
The current direction is changed.
The current direction has changed. Which current direction has changed?
Sir, it should be minus according to me.
Yeah, so it is confusing, right? Actually, it should be minus. You see, when I change the current, I change the current direction only for the second coil, isn't it? I didn't change anything with the first coil, correct? And I only changed the current direction of the second coil, and I also didn't change the voltage direction of the second coil, isn't it? So that is why anything which has I2 in it, that will change. So this is I2, by the way. So any term which has I2 in it will simply reverse, isn't it? And other will be and all the other terms should be simply the same, don't you think? Hello.
Yes, sir.
So please repeat.
Yes, sir. Yeah. So what I'm saying is, you see, from coming from here to here, okay. Not this. So in this particular example only, in between the one drawn in black and the one drawn in red, what have I done? Essentially, I have only changed the current direction of the second coil, isn't it? I have only changed the direction of the I2. Correct?
Yes, sir.
Yes, sir.
Yeah. So I have only changed the direction of the current for I2 for the second coil I2. So in these two equations, only those terms should be affected which have I2 in it, isn't it? Only those terms should be affected. Otherwise, other terms should remain exactly the same as they were earlier. Is that correct?
Yes, sir.
Yeah. So what should happen? So as in the first equation, you have I2 in only this particular term, right? So only this particular term changed its sign, isn't it? It became plus m from minus m, correct? Is that okay?
Yes.
So there was a lady asking something. Are you clear? You wanted me to repeat this. So are you clear? Swarna, yeah, Swarna, you have a doubt? Swarna, you raised your hand. You have a doubt?
Yes, sir. Sir, can you please repeat this?
Okay, so that is why I was asking you. Is it clear or not? So okay, so you have to speak up in between if you are not clear.
Yes.
Okay, so I was saying that so is this clear, by the way, when this is the scenario?
Yes, sir. This is the clear.
This is clear. Fine. Now I have simply changed the direction of I2. I have simply changed the direction of I2. Okay. Now this is not the case. This is I2. Okay.
Okay.
Now I have changed the direction of I2. I have not even changed the direction of V2. Okay, I have only changed the direction of current that is supposed to flow in the second coil. Right? This is coil number 1, this is coil number 2. This is coil number 1, this is coil number 2. I have only changed the direction of current which is supposed to flow in coil 2. Okay? So, what I am saying is, in these equations, in both of these equations, what should change? I mean, which term should be affected? If I have replaced this I2, if I have changed the direction of I2, then what should happen? All those terms which contains I2 in it, which contain I2 in it, in them, only those terms should be affected, isn't it? Other terms should not be affected.
Yes.
Because you see, V1 is equal to L1 di1 by dt. In this term, this is affected. This particular term is a function of L1 and I1 only, and both of them I have not changed, isn't it?
Yes.
So this should not be affected. While for the second term, this is dependent upon M and I2, right? And since I have changed I2, since I have changed the sign of I2, this also should be flipped, isn't it?
Okay. Got it.
Got it, right? So that is why it should be plus. Okay. Now again coming to the second equation. Again V2, the first term is dependent upon M and I1. Again it should not be changed, right? But only the second term, which is a function of I2, should be flipped in sign. Correct?
Yes, sir.
It should become minus. So this is what I was trying to explain to you. So at times it becomes very confusing if you have if you knowingly make it complicated in this manner. So what you should always try to do is what the professor also mentioned in his lectures, that you should also always try to follow passive sign convention for inductors at least. I mean, what do I mean by that? Whenever you change the direction of I2, also try to change the direction of V2. Okay, when you flip the direction of V2, then it again becomes this. Then both of them becomes. Then basically the L terms, whatever contain the L, they will not flip in sign, and only the M term will flip in sign. Okay. Hello.
Yes.
Yes, sir.
Yeah. So by the way, what will happen if so this is a little too messy, so let me write it again in this below. So what will happen if I do this? Oh. Yeah, tell me, what will be the equations here? Yeah, go on, tell me what will be the equations here. V1 will be equal to what?
L1 di1 by dt.
L1 di1 by dt, yes. And?
Minus M di2 by dt.
Minus M you said?
Yes.
Why did you say minus M?
Sir, the current is opposite direction.
Current is not opposite there. Current is exactly where it is supposed to flow. So see this, what happens? So in the first case, let's call this the first case, this is the second case, and this is the third case. So in the first case, so whenever you have this condition, so every term will be positive in these two equations when the sign is in this when the current is flowing in the dotted direction only, in the direction of the dots only. Okay, wherever the dots are placed, if the current is flowing into that point, then all the terms have to be positive. Okay. And by the way, this voltage should also be in this manner only. The voltage should also be corresponding to the passive sign convention. Okay.
Yeah. Okay.
In that case, all the terms will be positive. If any one of them is mismatched, then some terms will be negative and some terms will be positive. So here you see the current is actually flowing into where the dots are placed, right? In the first coil also you see the current I1 is flowing where the dot is placed. In the second coil also you see the current I2 is flowing where the dot is placed. Correct? Also you see the voltage here is actually following the passive sign convention. Voltage V1 is actually the plus terminal is placed where the current is flowing into the plus terminal actually here, right? The current I1 is flowing into the plus terminal here and the current I2 is flowing into the plus terminal here of V2, right? I2 is flowing into the plus terminal of V2, right? Like this, and here also in this manner. So that is why it is following the passive sign convention, and also it also has basically the current flowing into the dots. That is why all the terms have to be positive, isn't it?
Yes, sir.
Yeah. So it should be like this. So if that is clear, now tell me what will be the equation for this one. This example here. So instead of 3 millihenry, call it L1, and this is L2, and this is M. Now tell me what will be the equation of V21. What is V21? Okay, by the way, V21, if the arrow is given in this direction, it means this is plus, this is minus for V21. This is plus, this is minus for V22. So what is V21 now?
L1 I1.
L1 dI1
by dt.
Okay. And
plus M di2 upon dt.
What?
Plus
minus
M.
Minus M
Yes,
di2.
it should be minus
di2
di2 by dt. Correct. And what about the second one? V22. What is V22?
M di1 plus L di2 by dt.
You said M di1.
Yes,
minus.
Yeah, think about it. What should it be? Minus or plus?
Sir, minus.
Minus?
Plus, sir.
It should be plus. di1 by dt. And then?
Plus L2 di2 by dt, sir.
1 second. Oh, sorry. Yeah, think about it again. Should it be minus or plus?
Sir, it should be minus.
Yes, it should be minus only. Minus M.
M di1 by dt.
di1 by dt. And?
Plus L2 di2 by dt.
Yes, plus L2 di2 by
dt.
By dt, sir.
Yes. Right, correct. However, if let me try to confuse you. Okay, what will happen if instead of this being positive, this being negative, this would have been the condition? What will be the answer then?
We'll change the sign of V2 to.
Correct. We will only change the sign of V2 to. And anything else? So is it all, or do we need to do anything else? the person who told that we have to only change the sign of V to 2, I am asking whether
That's all,
this is,
I guess.
that's all right, because I have only touched V to 2, right? I have only flipped the sign of V to 2, so I should only worry about terms which contains V to 2, right?
Yes, sir.
Yes.
So that is why this is all. I have to do nothing else, and this can be equivalently described as V to 2 is equal to m times di1 by dt minus L2 times di2 by dt, right? So I have simply flipped the sign of all the, basically multiplied -1 in both the sides of the equation. Okay. So fine. So now that you have, I think you should not have any difficulties. So is that clear? I mean, this was all that I had to play with the mutual inductance. This is where people get confused in the dots. Okay. So you should be careful. If you are able to write these two equations, okay, then you will be able to solve all the questions related to mutual inductance. Okay, you just have to write these two equations of both the ports, V1 and V2 both. You just have to write it with proper sign. If you are able to do that, you will not be able to you will not get the question wrong. You will be able to solve it properly. Okay, so the one question that I wanted to discuss, I told that it's slightly tricky. I am leaving it for next week, because next week again we have to meet, and I want you to try it out once. Okay, I want you to try it out, and we'll discuss it definitely the next week. I will be posting these lecture notes, all the tutorial notes I will be posting, and you should be able to receive the link to the drive link. You will be receiving the drive link shortly. Okay, and also the lecture that I delivered today, or the tutorial that that we have all attended today, it will be again posted on my YouTube channel, and the link to that channel will again be shared to you. You can access it in the forum. It will be placed in the NPTEL forum. Okay, on the NPTEL website only, basically.
Yes, sir.
The course website only. So don't worry if you have if you lost some time in between, if your internet connection was not proper or something like that, it will be posted, so no need to worry about that. Okay, so we'll again meet next week, and as I told earlier, that these Saturday sessions, those who have joined late, it's for them. The Saturday sessions are solely for the purpose of solving questions which will help you to solve that particular week's assignment. So this was week one, right? This tutorial was week 1. So I have covered some questions which will help you to solve the assignment 1 questions. I guess that is due on 9th of August, right? August 9th. So you should start solving them, okay? And see whether you have any problem or not with that. And the Friday sessions, they will be covering in the session which will be taken on Friday. It will be taken by my colleague. Okay, he's also a PMR scholar, so he will be taking the sessions on Friday. His job will be to solve the assignments which have already occurred. Like let's say after 9th of August. 9th August I guess is Tuesday or Wednesday, right? 9th August is Wednesday, right? Which day, which day is 9th August? It's Wednesday, right? So after 9th August, I guess 10th and 10, 11. 11th of August will be a Friday. So on 11th of August, my colleague, he will be discussing the assignment 1 problems. Assignment 1 and assignment 2, maybe both of them. He will be discussing assignment 1 and assignment 2 problems. He will be discussing whatever is there in the assignments. I will be discussing whatever you will be needing to solve the assignments. Is that clear?
Okay.
Yes, sir.
Yes.
Okay, fine,
Yes,
fine.
sir.
So if that is clear, so you have only 2 sessions. Okay, the Tuesdays are not actually. Earlier the Friday sessions were to be conducted on Tuesdays, but it has been changed now, and I do not know whether the information has been given to you or not. But the sessions will be conducted on Fridays only. Okay, you will be notified about it. Don't worry, it will be announced in the announcement section of the forum or the course website. So there will be 2 sessions, one on Friday and one will be on Saturday. Okay, I will be conducting sessions on Saturday. My name is Mayank Anupam,
Okay.
and sorry for the camera problem today. I will solve it. I will sort it out next time. Okay. So if that is all, then thank you guys for joining today. Hope to see you in large numbers next time also. Welcome.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.